In this video, I'm going to be using the concepts that we have gone over in this module to solve some practice problems associated with solubility. So our first question says, lead chloride, which is slightly soluble, is dissolved in a beaker of water. At this given moment in the reaction, the concentration of lead is 0.0001 molar and the concentration of chloride is 0.0002 molar. Which way will this reaction proceed? So the first thing I want to do is draw a picture for our situation. So we have a beaker of water and we are dissolving lead chloride into this beaker. Where we will see some lead and some chloride ions start to form. So I definitely want to write an equilibrium reaction. So when I see in a question, which way will this reaction proceed? We need to decide whether Qsp is less than, equal to, or greater than Ksp. So we are already given the Ksp for this given question. So we can fill in that Ksp is 1.7 times 10 to the negative fifth. So we need to decide whether Qsp is less than, equal to, or greater than our Ksp value of 1.7 times 10 to the negative 5. So what we need to do is solve for Qsp. So we need to write an expression for Qsp, which is products over reactants, which in this case is equal to our lead ion concentration times our chloride ion concentration squared over 1, because we do not include lead chloride solid in our equilibrium expression. So what we need to do is plug in our concentrations at this given moment in the reaction so we can solve for Qsp. So at this given moment in the reaction, the concentration of lead is 0.0001 molar and the concentration of chloride is 0.0002 molar. So let's plug that in. So for lead, it is 0.0001 molar, and for chloride, it is 0.0002 molar squared. So Qsp, when we plug it into our calculator, I get 4 times 10 to the negative 12. So what we can see is Qsp is equal to 4 times 10 to the negative 12, which is less than 1.7 times 10 to the negative fifth. So we can see that Qsp is less than Ksp. So because every reaction is trying to get to a point where Q is equal to K, we need to increase Q so that it can become equal to K eventually. So we need to increase Q by increasing the products. So in order to increase the products, we should shift this reaction to the right. So this solid should continue to make more lead and chloride ions. So taking a look at our second question, lead iodide, which is slightly soluble in water, is dissolved in a beaker of water. So let's quickly draw a beaker for this situation. So we have lead iodide, which is slightly soluble. So we will see a very similar thing to lead chloride. We see lead ions and iodide ions. So let's write a reaction. So we want to find the concentration of lead and iodide at equilibrium. So what we can do in a situation like this is draw an ice table to solve. So one thing to note, we will never consider a solid in our ice table, so we can get rid of that. So what we need to do is figure out our change in our equilibrium concentrations of lead and iodide. So in this given problem, what we are assuming is that when this lead iodide is dropped into the water, the second that this lead iodide hits the water, we are assuming that this reaction is now started. Now, we are assuming that at the start of this reaction, this lead iodide hasn't had any time to make any ions yet. It is simply its full solid block sitting in this beaker of water. So we will say that the initial concentration for lead and iodide are both 0. So we're assuming this reaction hasn't started yet. We're going to run this reaction until it reaches equilibrium, where we can then find the concentration of lead and iodide ions. So we need to decide for our change column of the ice table, are we going to be adding or subtracting? Now, what we can do is look at our value of Q and look at our value of K to decide which way this reaction is going to shift. So Q SP versus KSP, we know our KSP is 1.4 times 10 to the negative 8. QSP is equal to our lead times our iodide squared. And filling in these values for our initial column of the ice table, we have 0 times 0 squared. So QSP right now is equal to 0. We have no products at this given moment. So Q is 0. So Q is less than K. So we know we have to increase Q and make more products and shift this to the right. So what we can do is add in our change column. So this will be plus X. Now we need to be careful for iodide. This is going to be plus X, but it is actually going to be plus 2X. Whatever the coefficient is in front of a certain species in your equilibrium expression, we need to put that same number in our ice table, in the change column of our ice table. So if this was a 3, we would change this to 3. So at equilibrium, we will see X and 2X for our lead and our iodide. So how can we solve for what X is? Well, what we can do is see that this is the equilibrium column for our ice table. So we know the equilibrium column is equal to K. So what we can do is write KSP, which is equal to products over reactants, which will be equal, in this case, to lead and Cl, or iodide, I should say, squared. So filling in what we have at equilibrium for lead, we can fill in X. So KSP is going to be equal to X times, and for iodide, this is going to be 2X squared. So all I did was fill in lead with X and fill in iodide with 2X. And remember to keep this squared. However, we know what KSP is. KSP is equal to 1.4 times 10 to the negative 8. So 1.4 times 10 to the negative 8 is equal to X times 2X squared. Now, 2X times 2X is equal to 4X squared, and 4X squared times X is equal to 4X cubed. So again, 2X squared is equal to 4X squared, and 4X squared times X is equal to 4X cubed. So solving for X, we can divide both sides by 4. So I'll pull out my calculator. 1.4 times 10 to the negative 8 divided by 4, and take the cubed root of that. I get X is equal to 0.00151. So we can fill in 0.00151 for X. So we know the concentration of lead will be 0.00151 molar at equilibrium. And for iodide, it will be 2 times that value, which will be 0.0030 molar. So this is how you would use an ice table to solve a problem like this, remembering to draw your beaker, write an expression, and when you fill in your ice table, you're assuming that at the beginning of this reaction, we would have no ions. Q would be less than K, so we want to proceed this reaction to the right to make more products, meaning we will plus X and plus 2X for our 2 iodide ions. And plugging this into our Ksp expression, we can solve for X and get the equilibrium concentration of lead and iodide ions.